So today we're kind of moving on from the quadratics just for a little bit. We'll be focusing a bit on what are called rational expressions. I want to be sure I wrote the right word. Rational. What are rational expressions? What's rational mean? Anybody know? What is the root of the word rational? Ratio. What is a ratio? Anybody know?
A ratio is like blank to blank, so it'd be like 5 or 6 4.
It's a comparison, right?
Yeah.
Between like two things, right? But it's also a fraction. Every ratio can be written as a fraction, right? Like 4 is to 2, you'd have 4 over 2, right? 6 is to 10, you'd have 6 over 10, right? 6 out of 100, 6 over 100, right? Those are ratios, right? And so every ratio can be written as a fraction, okay? And what do we know about fractions? What is okay about fractions? So we're talking about fractions. This is all what we're talking about, fractions, right? And the only thing is, the fractions are not going to be like the ones that you used to love dearly, like 2/3 and 7/15, right? They're going to be harder, right? There's going to be x's in them, and y's, and z's, and all sorts of weird things, right? So, what do we know about fractions? If I had a fraction, what can I never have in a fraction? Yes.
0 in the denominator.
Why? Is he right? Do you guys agree with her? It's a crime to have a 0 in the denominator, right? Do you know that? People will lock you up forever, right? You can't have a 0 in a denominator. Absolutely about why. The question is why.
That would just equal 0.
No,
What?
no. It'll be undetermined.
Why would it be undetermined?
Because, like, it's just saying how many times is 0 going to 5, which no one knows.
It's like
Yeah, how would you know? How would you know? You can't, I mean, it's impossible. Normally with a fraction, like, let's just do something like this. What? So let's do this. Like, let's say 10 divided by 2. What does that equal? 5. So when you have 10 divided by 2, you get 5, right?
Yes.
That means we could go backwards. We could say 5 times the denominator equals the numerator. You agree with me? Mind-blowing, right? Mind-blowing. But what if I do this? 5 divided by 0. A lot of people would say, oh, that's 0. You guys, focus. A lot of people say that's 0. Let's try that. Well, we got if this divided by this is this, then this times this must equal this. If 5 divided by 0 is 0, does 0 times 0 equal 5?
No.
No, so it definitely doesn't equal 0. How about 5? Does 5 times 0 equal 5?
No.
No. How about 100? Does 100 times 0 equal 5?
No.
No, nothing's working. Nothing's working. It's unsolvable, right? You see that? You can't have 0 in the denominator. But what about 0 in the numerator? Can you have 0 over 5? Is that okay? Yeah, that's okay.
Does that just equal 0?
Yeah, think about it. If 0 divided by 5, 5 goes into 0 0 times. 0 times 5 is 0. It works, right? But when it's in the denominator, it doesn't work, right? So you can't have 0 in the denominator. So the excluded, you know what excluded means, right? When you say exclude, if you're going to exclude somebody, hopefully nobody's experienced that, but if you're excluded from a math class, right, that would be a tragedy, right? It would mean, Violet's saying, I don't understand. I can see what she's thinking. But right, excluded means you're being pushed away, you're not allowed to join, right? Right? Well, the 0 is the excluded value. You cannot have a 0 as a denominator. What does that mean?
Wait, maybe. Is
So-
this your phone?
So let me ask this. If I gave you a fraction like this, 12 over x, what is the excluded value? What is the excluded value? of x, right? X can't be 0, right? So that's actually what you'd say. You'd actually say x cannot equal 0. That is your excluded value. Does that make sense? Then cannot equal, that's the way you write cannot equal. I don't know if you learned that or not. Does that make sense? Okay. What if I said yes? Oh, the phone fell? Is it? Whose is it?
Where's the bag?
Oh, it's not mine.
The bag was blue. It's right over there next to the wire.
Okay. Okay. All right. What if I gave you this? X plus 7 over 2x. Now, do I care about the x in the numerator? No. It doesn't make any difference. I could have that to be anything, right? Doesn't matter. The only thing I care about is the x in the denominator, right? Because I know the denominator cannot equal 0. Now, if I can't figure out what x would be to make that 0, I could always say, well, let's see. 2x equals 0. I could solve for x and see what it would be. Well, if I divide by 2, oh, x is 0. Oh, I could have figured that out, right? So again, I would have to say x cannot equal 0. That's my excluded value. Pretty straightforward, right? Yes? Okay, so that was my first example. Here's my second example. What if I gave you this example? 4 over x plus 10.
X can equal -10.
Do you guys agree?
C.
Or should it just be 0? X can't equal 0. No, it's not. X can't be. It's the denominator can't be 0, right? So if you can't figure that out in your brain, which you did, but if you couldn't, you could always say, well, x plus 10, what would x be for that to equal 0? You could actually set it equal to 0 and subtract 10, and you would say x is equal to -10, right? So x, the excluded value, x cannot equal -10, right? Does that make sense? Everybody gets this?
Vaguely.
You don't get this? Which part? Did you understand this one? X cannot equal 0. You understand this one? 2 times 0 is 0, right? What would x have to be for x plus 10 to be 0? -10, right? -10 plus 10 is 0. See what I'm saying? So if you can't figure that out in your brain,
So we're basically
like
just
that,
finding out
you
what
can always set it equal to 0 and solve for x. And that's what x cannot be. Does that make sense? Because -10 would make this denominator 0.
So instead of finding what x equals, we're finding the main thing that x cannot equal.
Exactly. It's just the opposite of sort of what we, it's the same process that we used to do to find the zeros, right? It's the same process. It's just that now we're saying, oh, well, they can't be that, though. It can't be that. Those are the values that are excluded. Now, what if I gave you something like this? Okay, that was 3. Let's do 4. Let's say I gave you what if I gave you x squared over x squared minus, let me think, does that work? 3 times 5? Yeah, that should work. What if I gave you that? This is where it gets a little harder, okay?
So it's like a quadratic equation.
Yeah, that's a quadratic trinomial, right? Not an equation, it would be an expression, right? There's no equal sign. But that's okay. That was a good, you noticed it. It's a quadratic trinomial. Can I factor that? The thing is, I know that I don't care about this x squared up here. I don't care. It could be anything. It doesn't matter. But I do care about this x squared and the x. I need to make sure that whatever would make them 0 does not happen, right? Otherwise, I've created an unsolvable thing, right? So I have to figure that out. The only way, this is really key, the only way you're going to find the zeros is to factor. You have to factor a quadratic trinomial. So let's factor it. Upstairs there is just going to be x squared. Now, I got to find factors of negative 15 that add to negative 2. How about 3 times 5? What if I made 5 negative? Would that work? All right, so I could then do my little thing. X plus 3 times x minus 5. You guys agree? Is that right? Let's just double check. 3x minus 5x is minus 2x. Yep, that's right. And 3 times negative 5 is negative 15. Perfect. All right, so now let's look at that for a second. I can't let the denominator equal 0. What are in this case, there's 2 possibilities that could make it equal to 0, right? You guys see that? It's just like finding the zeros in the quadratics that we used to do, right? To find the zeros, you set, if a times b equals 0, then either a equals 0 or b equals 0. You use that same process to find the excluded zeros. Do you know what I'm saying? The excluded factors, yes.
Wouldn't it be x is not equal to 3 or negative 3 and 5?
Right. So you would say, you could set it equal to 0 if you want to, but you can also ask yourself, well, what would x have to be for x plus 3 to be 0? It would have to be negative 3, right? Right? So x cannot equal negative 3, and or I'd have to add 5 to both sides to get, if x minus 5 equals 0, add 5. It cannot equal positive 5, right? Does it make sense? Fist to 5, you guys get that? The key is to factor the denominator, and then whatever, right after you factor, those are what you use. Now, I'll explain what I mean by that in a second. I'm going to erase all this. Now we've handled this part, finding the excluded value. Everybody knows how to find the excluded value, right? You set it, you basically factor it and set it equal to 0 and figure out what would x be for it to be 0. That's the excluded value. All right, now we're going to talk about simplifying rational expressions. So simplifying rational expressions. What if I gave you this? We'll just do a bunch of examples. How about x over 2x? How would I simplify that? What? Cross out the x's, right? That's the same as, this is the same as saying 1/2 times x over x. Wouldn't you agree with me? That's the same thing, right? So, yeah, the x's can just be crossed out, right? So really, all I have left is what? 2? 1/2, right? I have 1/2, so it equals 1/2. The 2 is in the denominator, has to stay in the denominator. But I also have to tell what is my excluded value. So my answer is just not to simplify, but I also have to state the excluded value. Now, there is no x in here, so I can say there's no excluded value, right? But there was an x there. You always have to go back to the original to see the excluded value, right? Or in this case, you'd have to go back to not the original, but the factored version, the original factored version of the original. Does that make sense? To find the excluded value. What can x not be? 0. So I say it's what x is. I say the answer is 1/2, and then x cannot equal 0. I'm done. That's my answer. All right, let's try another one. We'll slowly get harder. How about I say 5x over 5x plus 10. All right. Now, can I cross the 5x's out?
No.
Why?
It's not in those terms.
It's not what?
Both terms.
Right. It's got to be, if I wanted to cross the 5x, it would have to be here and here, right? Right? Because that's got a plus sign. So I've got it have to be in both, right? It's not. So, what would I do? Can I factor anything? Just not up and down, but can I just factor? Then I don't really care so much about the numerator. I will eventually. I will want to. My goal is to see, can I factor the numerator? I can't really factor 5x, right? Nothing to factor. Can I factor out a greatest common factor out of the denominator?
Yeah, 5.
could factor out a 5. So I've got 5x upstairs, and I've got a 5 parenthesis what? X plus 2. Ooh! Now I have factors, right? I have this times the blob, and this times this. So look, now I can cross out the 5s. Do you see that? Do you see that? Make sense? I can't here because it's just 5x here, and it's 5x plus something that doesn't have a 5x in it. But once I factor out the 5, then I can cross out the 5 itself. I could have crossed out the 5 because 5 goes into 5 and 5 goes into 10. That would have worked. But I would have had to do it. I would have had to do it like this. 5 goes into 5 once, 5 goes into 5 once, 5 goes into 10 twice. Right? I could have done it that way, but that's not the way I recommend. I recommend factoring and then crossing out your 5s, because then it's 5 times something, 5 times something, you can cross them out. It's not 5 plus something, right? So my final answer is x over x plus 2. Now, what is my excluded value? X cannot equal what? Yeah, I just go back, not to here, but I go to the first time I factored the denominator. I don't care about the numerator, I just care about the denominator. X cannot equal negative 2. X cannot equal negative 2. Mystify. You guys getting this? Making sense? Okay, awesome. Okay, number 3. How much time do I have? Okay. Hang on, I just want to see where we're at. Okay. How much time? Okay, well, let's try this one. How about 6x cubed minus 12x squared over 18x squared. So it looks like a mess. But always the goal with these is, this is the goal. Factor numerator, if possible, and then factor denominator. Right? And then see if, then try to factor, cross things out. Then cross things out. Cross out, right? Pass out, right? Okay, so we've got, what's my greatest common factor here? 6 and what? What? 6x squared, right? And then what does that give me? 6x squared times what is 6x cubed? X, right? And then minus what? 2, right? Am I right? Did I do that right? Okay. And then underneath I have 18x squared. Now what can I do?
Factor out of that.
What about x squared times x squared and x squared? Can't I cross those out? I can cross those out. And then what about 6 and 18? 6 goes into 6 once, 6 goes into 18 3 times. All right, there we go. So there's my answer. X minus 2 over 3. I simplified it. Does that make sense? You get that? Yeah. All right, but what's my excluded value?
Wait, you don't have one because there's not an X in the denominator.
Did I do something wrong?
No, there's just not an X in the denominator.
Ah, but there was here, right? There isn't there, but there you go back to the original, or the original factored. These are, since they're not really factored, it's this one I have to go back to. X squared, what would x have to be for x squared to be 0? X would have to be 0, right? That's the only thing, because if it was 1, it would be 1, right? So x cannot equal 0. So that's my excluded value. This excluded value is really pretty easy once you get the hang of it. It doesn't really take that long to do. Okay, so then what if I gave you something like this? Can I erase all this? Is that okay? It's kind of a race against the clock. Quite big. A race. Oh, a race. It's a race. I'm erasing. It's a race. Hey, that's pretty good. gave you something like this. X plus 3 over 2x squared times x plus 3 minus 7x plus 3. What could you do? Well, I'm noticing, wow, are you guys noticing there's an x plus 3 there, there's an x plus 3 there, there's an x plus 3 there? Good to know. But what is this? When you factor by grouping, right? Can you factor out a blob out of this? Okay, let's factor out the blob. So upstairs is just x plus 3, but downstairs, what is it?
2x squared minus 7.
2x squared minus 7, parentheses, x plus 3, right? Ah! So it's this blob times this blob. As long as they're just factors, they're being multiplied, I can start going up and down and crossing things out, right? I've got the same blob upstairs as downstairs. So I can cross this out and I can cross this out. Does that mean my answer is this? Don't write it yet, but does that mean this is my answer?
It's under 1.
Yeah, because look, this is in the denominator. What's really happened here? This is now x plus 3 goes into itself once. So upstairs I have a 1. Right? With me? I would do this to myself. Now I'm... Hi, Gary. All right, so now the question is finding my I just told you excluded values are really easy. Well, this one isn't quite as easy, but that's okay. It's not too bad. 2x squared, I'd have to set it equal to 0 to find out what x would be, right? 2x squared minus 7 equals 0. How would I just solve for x?
So first you'd add 7, right?
Right, exactly. So then I have 2x squared is equal to 7. I would now want to divide by 2, right? So I've got 7 halves, which is 3.5, right? So I've got x squared is equal to 3.5.
And then you need to find the square root of 3.5.
And then I've got to square root it. So x is equal to plus or minus the square root of 3.5, whatever that is. So x cannot equal plus or minus the square root of 3.5.
It's 1.870.
Okay, so x cannot equal 1 plus or minus 1.870. So I didn't mean to give you such a hard one. But you get it? You see what I mean? You just set it equal to 0 and solve, just like you've been taught, right? I saw that face. Okay, all right. So but this is clear, right? You know how to do this now. You can just factor it, right? What if I gave you a 4-term problem, right? You could factor by grouping, and then factor out the blob. You'll see some of those on the homework. And then last, what was this, number 5 maybe? Then 4? Well, who cares? We'll skip it. Okay, so we got 6. All right, what if I gave you, oh, thank you so much. What if I gave you, last one, this is our last one. Hang on. Okay, what if I gave you this? X squared minus 3x minus 10 over x squared plus 6x plus 8. What would you do? Okay, what would you do?
You would factor out
Man.
Okay.
What?
So you would basically factor both.
Right, remember, our goal is we factor the numerator.
So the first
Don't look at the denominator, just factor the numerator. Then factor the denominator, don't look at the numerator.
So the first
Then see if you have...
So the first
That!
So
I'm sorry, go ahead.
So the top would be
Factor
X.
the negative 10.
I would
it
be
would be
like
x plus
No.
3,
x plus
So,
x2, x
it's
minus
minus 5.
x minus 5, x plus 2.
Uh-huh.
Is that right? Okay, what about the bottom one? Factors of positive 8 that equals 6. 2 times 4.
Yeah.
Right? X plus 4 times x plus 2. Okay, so we factored them, right? Now, the x plus 2's are the same blobs. I can cross them out, right? So really, my answer is Don't leave yet. X minus 5 over x plus 4.
And then
But what is my excluded value? I have to take into consideration the x plus 2 even though I crossed it out. So
cannot equal.
x cannot equal negative 4, right? Because that would make this 0. Or x cannot equal negative 2 because that would make that 0. So excluded values are negative 4 or negative 2. And that's my answer. Make sense? Fist of 5, you guys get it? Okay. Kind of a long lecture, but so be it.